Okay, I will use the CPAT activity as a guideline to report you the good progress made by the instrumentation community. This include, of course, this is not an exhaustive list, include the annual instrumentation workshop and the DPF Instrumentation Award and Early Career Award and the Graduate Student Instrumentation Research Award called GERA. So the coordinated SBA RSTTR input when requested by DOE. So of course, the major role is the coordinating the generic R&D of U.S. high-energy physics instrumentation community. So the recent activities include the creation of the U.S. Detector R&D Collaborations, RDCs, to address the key technology identified during the 2019 Detector R&D Basic Research Needs BRN report and beyond, and other technology identified afterwards. So also the annual process for proposal preparation for lots of you are involving the comparative review, no for use to call FOVA. Of course, also other funding opportunities. You just heard the great information from Jeremy, Helmut, and Zach. We also provide community input for the European strategy update this year. Okay, first of all, workshop. You see the right side of the previous CPAT workshop. So this year is actually the UPenn is currently hosting the 10th CPAT workshop. So the registration and abstract now are open. Here's the link. So the early registration deadline is August 22nd. For students, we have reduced the registration fee. Please participate, engage. You will hear lots of excellent technical progress there. Okay, this is the instrumentation award and GERA. So you can find the award information through that link. Just remind the instrumentation award started 2015, GERA started 2028. Again, we thank DOE for this nice initiative to support graduate student instrumentation research award. It is actually important, one of the important contribution for the workforce development. Okay, here's the 2024 awardees. For instrumentation is Bob, for early career was Michaelis and Rao. So here's the citation. For the GERA, this is the 2024 fellow, Grace and Nora, and the runner-ups, Hayden and Sharon. Okay, congratulations to all of them. The 2025 process is ongoing. For the GERA application deadline actually is today. For the instrument award, the nomination announcement we will send out very soon. So in the P5 report, there's a area recommendation for detect R&D. Here's not go through the detail again, just a key information he's reminded. There's two categories. One is the generic. This includes recommendation 6 and 7. The other is targeted, recommendation 10. So CPAT is focused on the generic ones. Okay, in the report, actually highlight the RDC, the important of creating RDC collaboration, R&D collaboration, RDCs. So to make sure we can basically achieve a coherent R&D program with, reduce the duplications, to address the common challenge, and also emphasize to collaborate, participate in the CERN detect R&D groups, the DRDs. So basically in the P5 report, both creation RDCs and collaboration DRDs are emphasized. So the current situation about the certain DRDs. So I think probably there was some confusions or still some confusion how the DRD works because the nature of organization seems different DRD by DRDs. I just used a couple of slides from DRDC chair Thomas Berger, so give you some basic, hopefully can clarify a little bit. The DRD goal is perform strategic R&D that adopt the NASA technology readiness level definition, which means DRD is a strategic R&D from TRL3 to TRL6. For experiment, roughly cover start from experiment letter of intent to the TDR phase. That's roughly the DRD's cover. Okay, so it's can either through the different technology options, improve the radiation hardness or scaling up. That's basically, you can see by its nature, DRDs cover both generic and project-specific target R&Ds. Let's just please keep that in mind. Okay, there are 8 DRD collaboration are established. So you can see this list here. Some have previous history, like base catalyst or RD51. Some are new, like the photon detector, liquid detector, and quantum sensory. Of course, some also the transversal activities like electronics and mechanics integration. Okay, we encourage, I think the US community already actively participates in this. We still encourage you have not done so. In the US, so that RDC was established with some consideration, at least here, the key point. So detect R&D efforts in many different technology areas are essential to realize the future our experiments. This is spanning all the frontiers in high physics, also nuclear physics. So much as this effort needed require collaboration and coordination, because the require for given technology required expertise, resource, new idea, often leaving multiple people, institute labs. We only by bringing all these pieces together, we can hope to realize a given technology challenges. So in a resource limited environment, we need to really cohere our effort, minimize duplication, and build up progress happening elsewhere. So note the future project likely already have or is having its own R&D organization. This become target R&D. We heard the good progress yesterday for the Higgs factory HFCC. That's one of the target R&D organization. So RDC are created with generic R&D focus, but are actively working with those target R&D to optimize resource and promote work being done. Okay, so work closely. So notice some ongoing R&D project activity comprise both generic and target aspects. So RDC we're working with those for the smooth transition and involvement once it's time is proper to become target R&D. We are working with those individual PIs in all projects. So RDC continuously enhance our communication with certain DRDs. So as I showed earlier, so that each DRD basically have a scope, probably roughly a US RDC and all the relevant project space RDs. But DRD and RDC do not have one-to-one match. This might cause some additional confusion. Okay, this is the list of the RDCs. There's 11 of them. I will not go through the detail. On the right side, you see the current coordinators. If you have not engaged or you want to engage, discuss any particular topic, please just directly communicate with all of them. Okay, so you notice this is a technology area collaborations for those broad cross-cutting topics such as workforce development and facilities. Currently is residing in the different RDCs. We may revisit how to do this in the future, but currently is discussing the individual RDCs. Okay, since 11 of them, I certainly will not have enough time to go through all the good technical progress made. I just highlight a couple. First one is RDC to photon detectors is focusing on improvement and development of the novel photon detectors for light particle detectors. Though some progress was highlighted during the 2024 workshop with improved timing resolution through detector radar electronics as the Jinlong sentinel separation. Also lots of improvement for PMTs, CPAM, and SPATs. Also new photon cells material for UV and VUV detection. That's become very important for our future experiment. Also nanoscale sensor beyond the diffraction limit. The other highlights are DC7 low background detectors. This has become very important for dark matter search or neutrino experiments. So this is cross-platform and cross-project R&D to solve those problems together. So some good progress was highlighted again during the 2024 workshop. So the CCD now can discriminate nuclear recoil and electron recoil go to very low, and now it's kind of few keV. The future even go down to 50 to 100 EVs. So through the SBIR, so that some really the growth radiation pure tungsten technology, tungsten material is cheap and can be used for future to basically, let's say, replace the acid lead technology, lead technology. Also, some new facility being developed as part of a next experiment to actually measure as detect the materials for random contamination. So, okay, this is the technology progress. I'll go some procedure activity we also have been doing. So one is the how to prepare the proposal for the comparative review. In 2024, what we did is through the wider paper process, basically the RDCs invite the community to submit a white paper for the potential proposal scope they want to submit to DOE. So through that process, we realized, the community was largely very supportive, open, welcome, and vocal. The process, we had a very agile process because we realized some new effort, some of the new coordination strategies, some of the new information. Yeah, overall the community was very supportive. So we collected more than 30 white papers. So you can find the list if you're interested on their webpage. Then we have the community workshop afterwards. Invite all of them come to present their white paper. Basically, a subset of them actually present. It's about 15. So afterwards, CBAT executive committee and RDC coordinator rank the white paper with the predefined rubrics. So basically the outcome was not to the community broadly. Afterwards, the RDC and the CPAD, we actually work with the proponent to prepare their proposal, provide like a collaboration letters or help them to how to prepare the whole process well. Okay, that's actually the outcome. So there was 3 white paper ranking the top overwhelmingly. Also another 2 also not far away. Among the 3 highly ranked one, so 1 did not submit a proposal. Actually, 1 actually get awarded. The number 3 get awarded. The number 1 was not submitted the proposal. That's a major outcome. We also act on some of other opportunities. Jeremy actually explained this very well. So first one, the quantum side. For basically what we did, RDC Act is only act on concurrent priorities and facilitate collaboration. So what we did is communicate with PI, with either RDC Act meetings or other methods, basically understand whether a given PI is leading a particular proposal. If so, what kind of priority their proposal is in line with or potentially can benefit. Then also when they need a more collaborator or not. Based on the information, RDC basically assess whether there was a lack of proposal, consistent with RDC at high priorities. Also communicate with, collected the information with the individual PIs used for the collaboration, make the connection among them. So that's what we did. Similarly, for the microelectronics, the RDC did exactly the same thing. Okay. The other one is the hardware II for help. We did not act on because we realized this is first of all this is a computing help call, and we also aware CPSC was being formed at that time. Of course, you hear CPSC later. Okay, so we did all this, so probably not ideal. So that's why your feedback will be greatly appreciated for us how to act on this kind of large, let's say, future cross-frontier, even the cross-funding agency opportunities. Okay, for 2025, based on the feedback we get in 2024, with 2025, we use a different approach. We will not do the ranking. We are adopting a mini BRN process. Basically, each RDC, we articulate the RDC priority with their own community, produce a handful priority list with a very consistent format, with a label, with a concise definition, with a brief dictionary. Then we combine all of them into one document or make available to the community. We will post in the archive to provide a site for reference. We encourage all the proposals of the PI when prepare the proposal and cite the priority document and highlight the scope consistency with the individual priority in the RDCs. We'll also prepare the collaborative letters for the proposal as needed. Basically, this is like a mini BRN process. We will, if this work well, we'll basically probably repeat the process annually. Okay, this actually give you a quick snapshot where we are. This is RDC 3 R&D priorities. You can see the 5 of them. You'll see they try to address in the low mass, high radiation, and based all artificial intelligence. Yeah, so this is very draft, but hopefully that we can share with community soon. So this is the timeline. In February, we, RDC coordinates and the CPAD, we dismantled the feedback get from last year. We decided to use a new approach. Then since then, we collect all the priority described available during the past years. Then we started to work with our community to inform them, improve, and agree on the RDC priorities. We had a community meeting in March. Then currently, RDC coordinates actively trying to finalize all the RDC priorities to produce a final document. We are planning to have a community meeting next Thursday. So hopefully we can share the almost final document, then start to prepare the collaboration letters for those PS proposal for the DOE comparative review novel this year. Okay, so we also provide input to the European strategy. So after consulting with the DPF and had a community workshop, we submitted one white paper, ID 93, if you go to the European strategy webpage. So for detect R&D, we closely communicate and collaborate with the DRDCs. So they also submit the similar thing. Ideas reiterate the key message, the importance for instrumentation in SNOMED report and the P5 report. We emphasize the need of a continuous strong support for instrumentation. For targeted part, we basically simply briefly cite those project-wide variables like Higgs factory, Muir collider, or Dune phase 2. We only focus on generic, summarize the work package priorities and highlight technical progress. That's the major context in the document. So for broad and cross-cutting matters like facility, workforce demand, we just use the SNOMED report material. So yeah, we also strengthen the broad collaboration with DRDs in the document. Okay, one slide for synergy with nuclear physics. We certainly not go through detail, but we know there's greater synergy between high physics and nuclear physics in many technology areas. Here, I just took two major areas in the long-term planning report released 2023 for nuclear physics. One, of course, the detector for peak detector for the EIC can through from silicon-based tracking, and gas detector, different technology for calorimeter, different technology for PID and electronics. Also for ton scale, the neutralized double decay for 3 candy qubit. And next one legend, they use either bolometer, liquid xenon TPC, or high purity germanium detector in the liquid arc. So this have lots of aspects of the synergy without going into detail. Okay, I just want to use these slides to reiterate some key message we present in various forum occasion, the importance of the instrumentation ecosystem. The key to success are people, facility and resource, and connection and collaborations. So we need advanced workforce and resource research collaborations. We need a unique facility and capability. And the connection to other programs, other office agencies, even the private foundation, commercial partners, and global collaboration. That's important. All these together will ensure access. With that being said, let me summarize by saying thanks to the DPF for this community. We have a much improved state of the instrument community after this exercise. Create RDC communication, prepared proposal is much better. Much engaged community. We're really glad to report this big change recently. Okay, CPAD RDC actually articulate the RD priorities. If you have not provided input yet, we encourage you to do so through the RDC coordinates, and we encourage you to join those RDCs. Here, the CPAD mailings note, this is a community, not a project. Thank you.
We're checking to look for questions. We have a couple questions in the live doc, and I think Roger Rusak is still typing. Actually, I was going to ask a question, which is maybe it's which is your favorite child, but of the really novel new technologies in instrumentation, which do you think will have the most impact in the next decade?
That's indeed I will not say which one, but I certainly say there are a few. If you see the list, right, you have quite interesting technology being pursued in various R&Ds. I will not say which is my favorite. You can see the, very advanced photo detectors, or we are talking the really, pushing the limit for the solid state, or not even beyond the silicon material. So have very, advanced ASIC design go to, a really small features, of course, quantum and semiconductor detector. You just heard Jeremy give you quite a few good examples. It's quite a few of them. I do not have a favorite child, but I think we have quite a few normal technology. Of course, it assume we have, let's say, reasonable support, right? It's come to the support level, which you can choose. That's why the prioritization and the reality, it will be different probably.
Okay, so the next question is from Roger Rusak. How are priorities defined within CPAD? There are multiple good ideas that would be of interest, highly speculative, low probability of success, and less speculative or more relevant. So there's two ways of looking at the blue sky or the stuff we need right now.
Yes,
that was
for
me
CPAD,
interpreting the question.
Yes, thanks. Yeah, for CPAD, we emphasize first the blue sky one. It's generic. We emphasize the blue sky more. Yes, that we can say. Yeah.
There's a comment. I think this is from Roger. Yeah, can people please remember to put their names on things? Comment probably from Roger. The timing of this seems to be out of sync with the comparative review process.
Actually, no. Actually, we're targeting, for example, what we time, let's go back to the timeline we had here. So ideas, we share the document, let's say, beginning of next month. I think the people are actually prepare and submit the proposal, right? I think deadline is September. So ideas provide this in time so people can cite, quote, make the, adjust in the proposal. That's the exact idea. I think we try to think, if this is not correct, just remind, we can correct our course to make that happen. But this aim to be consistent with the process.
Okay, so I'm going to go. Roger still has another question, but Lindsay Gray wrote, you mentioned the hardware-aware AI proposal as being under CompHEP and therefore not a concern of the DRDs. Could you clarify how these two entities should interact given that on-chip ML is rapidly becoming on-shell?
Yes, I think that what we did, first let me clarify the statement what we made here. Basically, we did not act on, which means we did not act on the coordination rule or connect the people. But with this actually discussed, in the various RDCs, particularly 4 and 5, individual also participates in the individual proposals. We just did not act on the coordination part. Okay, we actually individual they produce the proposal that we are discussing RDCs. But yeah, we did act on individually, but we did not act on the coordination. For the future, that's us. We really welcome community input how we do this differently, do better if you prefer for this kind of cross, let's say frontier, even cross agency, the large opportunity. I think the coordination will be important, but how do it? We are really the community. We are here to hear the community input, how we do better or more effective in the future.
Okay, Roger has a question, and then Joe Kroll. So first, Roger, please discuss the interaction through the SBIR awards with HEP groups.
SBIR, which one? Roger is talking about this part. SBIR, SDR. The input here basically is regularly, DO will ask, basically collect the input, say what you need to be for the next SBIR or etc. call, what kind of technology requirement, which areas important we want to see. Basically, the CPAD basically have a committee or individual expert will provide those input. We also help to identify proposal review every year. Basically, large helmet can accommodate this better. Why just let helmet comment this particular one?
So every year we have an FOA for SBIR projects that's accompanied by specific topics language, meaning specific technologies with specific requirements that we would like a small business to address. And we collect input from the community, in part via CPAD for such topics and for specific requirements that we would like to see addressed. That's one aspect. The other one is every year we get a very large number of SBIR proposals, and we need help in reviewing them. And so we engage via CPAD experts in the community to help us for this process.
Thanks, Eamon. Hopefully this addresses Joe's question.
Okay, okay, so there's a question from Joe Kroll, which is, I thought that originally CPAD was supposed to have funding associated with it that we could apply for. Is this still the plan, and when might this funding be available? And I will comment that DPF could in principle apply for funding, but we rely solely on the $10 that our around 3,000 members give us every year.
Thanks, Katie, for answer. Yes, CPAD does not have funding. Exactly. Yes, thanks.
Yeah, I think it's possible that we APS does occasionally apply for funding from various federal agencies for APS. It is conceivable that one could do such a thing, but I think right now CPAD does a great job in facilitating people's own proposals to the funding agencies. Okay, and the last question right now is from Marcel Desmarteau at Oak Ridge, and he says, you mentioned the synergies with nuclear physics. There are tremendous synergies across the Office of Science overall, for example, the light sources. What is CPAD doing to leverage activities across the overall Office of Science and also in the area of quantum information science?
That's excellent question, Marcel. We have not. That's something we plan to do, but we have not there yet. That's once we put the current load off a little bit, we'll engage indeed more of it, like APS, for example, or quantum sensor things. Yes, that's a great suggestion. We should talk about offline. That's an excellent point. Yeah, we are not there yet, but it's on our list.
Does Division of Nuclear Physics have a similar organization that we should be coordinating with?
They have a R&D program, but I'm not sure they have such a probably Helmut can help us comment on this one.
So they do not have a generic detector R&D program. All their R&D happens in the context of specific projects. And I'm not aware that there is an organization equivalent to CPAD that is focused on NP. But as Jinlong said, CPAD's really working towards making better connections with NP so that we can realize the many synergies that there are. Our technologies have in many areas become so similar that it really calls out for joint efforts.
Okay, so I think we actually have time for other questions if people raise their hands, but otherwise we're going to move on to the next talk.
Thank you.
Thank you very much. That's a great talk. Please post your slides because there's a lot of good information in there.